Welcome to our deep dive into the world of asynchronous programming in JavaScript.
Oh, yeah.
Today we're going to explore how your code can kind of juggle multiple tasks at the same time without getting stuck,
Right.
making your web applications, feel smooth and responsive and all that.
Exactly. Asynchronous programming is kind of the secret sauce behind, a lot of modern web experiences,
Okay.
from fetching data from APIs to handling user interactions seamlessly.
So before we kind of jump into the details of it all,
Sure.
can you maybe paint a picture for us?
Yeah.
What is the problem that asynchronous programming solves?
So imagine you're on a website
Okay.
and you click a button to submit a form.
Mm-hmm.
In a synchronous world, your browser would basically freeze.
Oh, okay.
It wouldn't be able to do anything else until that form submission process is complete.
Right.
And that could lead to a very frustrating user experience with delays and, that spinning wheel of doom.
The spinning wheel. Yeah. Yeah. We've all been there.
Yeah, exactly. And asynchronous programming lets different parts of your code run at the same time without blocking each other.
Okay.
So while that form is being submitted in the background, you can still interact with other parts of the page,
Okay.
which makes the application feel much more responsive and user-friendly.
I see. So it's like having, multiple lanes on a highway instead of a single congested road.
Precisely.
Okay.
Now let's talk about how JavaScript handled this asynchronous juggling act in the early days.
Oh.
It all started with callbacks.
Callbacks. I've heard of those, but
Yeah.
they always seemed a bit mysterious to me.
Sure.
Can you demystify them for us?
Of course. So a callback is basically a function that gets passed as an argument to another function. And it's executed later when a certain task is complete.
Okay.
You can think of it like leaving your phone number with someone and saying, call me back when you're done.
Okay. So like giving instructions for what to do after an asynchronous operation finishes.
Exactly.
Okay.
And it worked for a while, but as applications became more and more complex,
Right.
and we had to manage multiple asynchronous operations,
Mm.
callbacks led to what we lovingly call callback hell.
Callback hell. That sounds ominous.
It can be.
Okay.
It's like, imagine trying to follow a recipe where all the steps are scattered across multiple pages with arrows pointing you all over the place.
Yeah.
It quickly becomes very difficult to understand the flow of logic and to debug when things go wrong.
Ooh, I can relate to that. Nothing worse than a disorganized recipe when you're trying to cook.
Right.
So how did we escape this callback hell?
Well, that's where promises come in.
Okay.
They kind of revolutionized asynchronous JavaScript by providing a more structured and elegant way to handle these time-dependent tasks.
Promises, they sound almost too good to be true. How do they actually work?
Yeah, so a promise represents the eventual outcome of an asynchronous operation.
Okay.
Think of it like ordering something online. You place the order, that's the promise,
Okay.
and it has three possible states. Pending means, the order is being processed, fulfilled, means the order arrived successfully, and rejected means, well, there's a problem and you didn't get your package.
So it's not just about the immediate result, but about handling the different possibilities of what might happen in the future.
Precisely. And the beauty of promises is that they provide a clean and readable way to manage all these different states.
I am all for clean and readable code.
Right.
Can you show us how this works in practice?
Oh, absolutely.
What?
So let's imagine we want to fetch some data from an API.
Okay.
Using promises, we could write something like this.
Okay. And we'll have the code on the screen here.
Yes, you'll see the code on the screen.
Perfect.
So fetch, and then in parentheses, the URL,
Okay.
dot, in parentheses, data arrow, and then curly braces and a comment. Do something with the data
Okay.
and close the curly braces. Dot catch and parentheses, error, arrow, and then curly braces.
Oh.
Handle any errors gracefully. Close curly braces, and then a semicolon.
Okay, so I'm seeing a pattern here with these like dot-then methods.
Yeah.
What's going on there?
So the dot-then method allows you to attach callbacks that will be executed when the promise is either fulfilled or rejected.
Right.
So in this example, the first dot-then handles converting the response from the API into JSON format.
Okay.
The second dot then gives us the nicely formatted data to work with.
Okay.
And finally, that dot catch handles any errors that might have occurred during the process.
So it's like a chain of events. Each step is triggered by the previous one.
Exactly.
This seems much more organized than those nested callbacks we were talking about.
It is. And this chaining capability is one of the most powerful features of promises.
Okay.
You can create these complex sequences of asynchronous tasks in a way that's really easy to read and understand.
So it's not just about fetching data. We could chain together any series of asynchronous operations.
Absolutely.
Yeah.
For example, you might fetch data from an API,
Mm.
then process that data, then update the user interface based on the result, all within, a clean and manageable chain of promises.
This is all starting to click into place, but I have a confession.
Sure.
I sometimes get a little nervous about things going wrong, especially in asynchronous code, where things are happening kind of in the background.
Right.
How do promises help us handle errors gracefully?
That's a great question, and error handling is absolutely crucial in asynchronous programming.
Yeah.
And promises make this much easier with the .catch method.
Okay.
So by attaching a .catch to our promise chain,
Okay.
we're creating a dedicated path for dealing with any errors that might arise.
Okay, so it's like having a safety net in place to catch any unexpected issues.
Exactly. Let's say our API request fails for some reason.
Oh.
Instead of crashing our entire application, the .catch method will intercept that error
Okay.
and allow us to display a user-friendly message
Okay.
or take some other corrective action.
That sounds much better than a cryptic error message that confuses the user.
Definitely. Graceful error handling is all about, providing a smooth user experience,
Right.
even when things don't go as planned.
I'm starting to see the real power of promises.
Yeah.
They bring order and predictability to this world of asynchronous JavaScript.
They do. And they lay the foundation for even more powerful techniques like Async,
Okay.
which we'll explore in a bit. But first, let's take a closer look at some common use cases for promises,
Okay.
like fetching data from APIs, which is, a staple of modern web development.
This is getting really exciting. I can't wait to see those promises in action.
Yeah, me too.
So let's maybe
Let's dive in.
let's dive in
Yeah.
to those real-world examples.
All right.
I'm ready to see those promises in action, especially when it comes to fetching data from APIs.
Yeah.
It feels like almost every web application these days relies on pulling information from external sources.
You're absolutely right. Whether you're building a weather app, a social media feed, or an e-commerce platform, chances are you're going to be working with APIs.
Okay.
And promises make this process so much smoother.
Okay, so let's get specific.
Okay.
Walk me through how we'd use promises to fetch data from an API, say to get a list of posts from a blog.
Let's do it. We can use the fetch function in JavaScript, which is designed to make network requests. And the great thing is that fetch itself returns a promise.
So we're already in promise territory from the start. I like it.
Here's a simple example.
Yeah.
Imagine we want to get posts from a blog API.
Okay.
We can use fetch to make a request to the API endpoint, and then use .then to handle the response.
Okay.
So you'll see the code on the screen, fetch open parentheses,
Okay.
https.api.example.com, flood post close parentheses, .then open parentheses response, arrow response, .json, open and close parentheses, dot, then open parentheses, post arrow, and then open curly brace.
Yeah.
Now we have the posts data ready to use, and then we'll just do a console.log, open parentheses, post close parentheses, and then close the curly brace dot, catch open parentheses, arrow, and then open curly brace on console.arrow, open parentheses. Something went wrong. Comma, error, close parentheses, and then close the curly brace, and then a semicolon.
Okay, let's break this down. The first dot then seems to be handling the raw response from the API.
Yeah.
What's that response.json doing?
Great question. API data is often sent in JSON format, which is a way to structure data that's easy for machines to read.
Okay.
The response.json open and close parentheses method takes that raw response and parses it into a JavaScript object that we can work with easily.
So it's like translating the API's language into something JavaScript understands, and then the second dot then gives us access to that nicely formatted data.
Exactly. Now we have the post data in a form we can use to display it on a web page, manipulate it, or do whatever we need to do with it in our application.
And of course, we have our trusty .catch at the end to handle any errors, like if the API is down or if there's a network problem.
Always be prepared for the unexpected. Robust error handling is a sign of a well-structured asynchronous application.
This is all making so much sense. But I've heard there's an even more modern and perhaps more elegant way to work with promises. Async. Is it as magical as they say?
It can feel pretty magical. Async is a syntax that makes working with promises feel more like writing synchronous code,
Okay.
which can be easier to read and reason about, especially for beginners.
Ooh, I love when things become easier to read. Can you give us a taste of how Async works?
Let's rewrite our previous example using async. So async function, get posts, open and close parentheses, and then open curly brace, try open curly brace, const response, touch open parentheses. https://api.example.com/posts, close parentheses, semicolon. Const post equals await response, .json, open and close parentheses, semicolon, and then console.log, open parentheses, posts, close parentheses, semicolon, close the curly brace, and then catch, open parentheses, error, close parentheses, open curly brace, console.error, open parentheses, something went wrong, comma error, close parentheses, semicolon, close curly brace, and then we'll call the function getPost, open and close parentheses, semicolon.
Okay, this does look a bit cleaner. I see we're using the keyword async to define our function. And what's that await keyword doing?
Await is the key to the magic.
Okay.
It essentially tells JavaScript to pause the execution of the function until the promise is settled, either fulfilled or rejected.
Okay.
So in this case, we're waiting for the fetch promise to resolve, and then we're waiting for the response.json promise to resolve.
It feels almost like we're writing regular synchronous code where each step happens in order, but it's still handling all those asynchronous operations behind the scenes.
That's the beauty of async await. It allows you to write asynchronous code that reads more naturally without the nested callbacks or the sometimes complex chaining of than methods.
I'm starting to see why people love async await. But you mentioned that it's built on top of promises. Does that mean we always need to understand promises to use async await effectively?
It's essential. Async await is not a replacement for promises, but rather a syntactic sugar that makes working with them more pleasant. If you don't understand how promises work, you might run into subtle issues or find it difficult to debug your asynchronous code.
That makes sense. It's like learning to drive an automatic car. You still need to understand the basic principles of how a car works, even if you don't have to shift gears manually.
A perfect analogy. Mastering promises is like understanding the engine of asynchronous JavaScript. Once you have that foundation, you can use tools like async await to drive smoothly and efficiently.
This is all incredibly insightful. I have a question. We've been talking about these beautiful sequences of asynchronous operations, but what happens when multiple things are happening at the same time trying to access the same data? Could that cause problems?
You've hit on a crucial point. When we start dealing with multiple asynchronous operations running concurrently, we need to be aware of potential concurrency issues.
Concurrency issues? That sounds a bit intimidating. Can you give us an example of what might go wrong?
Imagine you're building a simple counter on a web page that keeps track of how many times a button has been clicked.
Okay.
If multiple users click that button rapidly and you're updating the counter asynchronously, you might run into a race condition.
A race condition, like those asynchronous operations are competing with each other.
Exactly. Let's say 2 clicks happen almost simultaneously. One operation might read the current value of the counter, let's say it's 5. Then before it has a chance to update the counter to 6, another operation might also read the value as 5. Both operations then try to update the counter, resulting in it only being incremented to 6 instead of 7.
Ah, I see the problem. It's like 2 people trying to edit the same document at the same time. Things can get out of sync.
Precisely. And these concurrency issues can be tricky to debug because they might not happen consistently. They often depend on the timing of events and the order in which asynchronous operations complete.
So how do we prevent these asynchronous traffic jams? Are there any tools or techniques we can use?
Absolutely. There are several strategies for managing concurrency and ensuring data consistency in asynchronous applications. One common approach is to use synchronization mechanisms like locks or mutexes.
Synchronization mechanisms. Those sound like traffic signals for our asynchronous operations.
That's a great way to think about it. A lock essentially prevents multiple operations from accessing a shared resource like our counter variable at the same time.
Okay.
Only one operation can hold the lock at a time, ensuring that the counter is updated correctly.
So it's like having a bouncer at the door, making sure only one person enters the club at a time.
Exactly. Another technique is to use atomic operations, which are operations that are guaranteed to be completed as a single indivisible unit.
So it's like an all-or-nothing operation.
Yeah.
No chance for those partial updates that can cause inconsistencies.
Precisely. Atomic operations are often provided by the underlying data storage systems or libraries you're using.
Okay.
And they can be very effective in preventing concurrency issues.
This is fascinating stuff. It feels like we're going deeper into the inner workings of how asynchronous code behaves in the real world.
We are. And these concurrency issues, while potentially complex, are incredibly important to understand, especially as you start building more sophisticated applications that handle a lot of data and user interactions.
I'm definitely feeling the need to digest all of this amazing information. Maybe it's time for
To wrap things up.
to wrap things up. and explore some final thoughts on this asynchronous journey.
Yep.
Okay, so we're back for the final part of our deep dive into JavaScript asynchronous programming. We've covered so much ground, from those early days of callbacks to the elegance of promises and the power of async await.
Yeah, it's been quite a journey.
It has been quite a journey. So now that we've explored all these concepts,
Yeah.
what are the key takeaways for our listeners? What should they be thinking about as they go forth and build amazing JavaScript applications?
I think first and foremost, embrace the power of promises.
Right.
They're really the foundation of modern asynchronous JavaScript development. Mastering promises is going to make your code more readable, maintainable, and reliable.
And don't be afraid of async await.
Right.
It can make working with promises feel much more natural, especially when you have a series of dependent asynchronous operations.
Absolutely. It's all about choosing the right tool for the job. And as you gain experience, start thinking about potential concurrency issues and how to address them using techniques like locks or atomic operations.
So we've talked about, a lot of these abstract concepts, but can you give us some concrete examples of how all of this applies in the real world?
Certainly. Imagine you're building a real-time chat application. Asynchronous programming is essential for handling incoming messages, updating the chat interface, and sending outgoing messages without blocking the user experience. Promises and async await would play a crucial role in managing those asynchronous flows.
And what about something like a web application that interacts with a database?
That's another perfect use case. Database operations are often asynchronous, especially when you're dealing with large datasets or complex queries. Promises provide a structured way to handle the results of those queries and update the application accordingly.
So it feels like asynchronous programming is just woven into the very fabric of modern web development.
It really is. From simple form submissions to, complex real-time applications, mastering asynchronous programming is essential for building responsive, user-friendly, and robust web experiences.
So this has been such an eye-opening deep dive. I feel like I have a much deeper understanding of how JavaScript handles those time-dependent tasks and the tools and techniques that we can use to kind of manage that complexity.
Good.
So where should our listeners go from here? What advice would you give them as they continue their asynchronous adventures?
Well, I think practice. The more you experiment with promises, async await, and concurrency concepts, the more comfortable you'll become. Don't be afraid to make mistakes. That's how we learn and grow as developers.
And never stop exploring. The world of JavaScript is full of, all these amazing libraries, frameworks, and tools that can really help you build incredible things.
On that note, I want to leave our listeners with a final thought to ponder. We've talked about the power and flexibility of asynchronous programming.
Right.
But as with any powerful tool, there are potential downsides.
Ooh, I'm intrigued. Tell us more.
Asynchronous code can sometimes be a bit more challenging to debug and reason about than synchronous code.
Yeah, that makes sense.
And managing concurrency can introduce a whole new set of complexities. So as you embrace the power of asynchronous programming, remember to proceed thoughtfully, test thoroughly, and always be mindful of those potential pitfalls.
That's a wise reminder. It's all about, striking a balance between harnessing that power of asynchronicity and being aware of those potential challenges.
Exactly. With careful planning, thoughtful design, and a good understanding of the tools and techniques at your disposal, you can build truly amazing asynchronous applications.
Well, this has been just an incredible journey into the world of JavaScript asynchronous programming. A huge thank you to our expert for guiding us through this complex landscape.
It's been my pleasure.
And to our listeners, keep experimenting, keep learning, and keep building amazing things. Until next time, happy coding.
Happy coding.